In this example, I have a 4, 45, 188, 493, 1020, and 1829. What I'm going to do is find the first set of differences between 4 and 45, 45 and 188, 188 and 493, 493, 1020, and 1020 and 1829, and these are the numbers that I came up with. 41, 143, 305, 527, and 809. None of them are consistent, therefore there is no finite difference, and I need to move on to a second level, or second degree. So what is the difference between 41 and 143? That's 102. What's the difference between 143 and 305? That's 162. And as you see, the next terms are then 222 and 282. All of these are different numbers. None of them are the same. I have yet to find my finite difference. We move on to level 3, a third degree. I got a 60, I've got a 60, I've got a 60. This is my finite difference. Because it took 3 levels to get where I need to go, I'm going to need a third degree polynomial to create the sequence. What I need to do is I should have a table that I can use to match up. And so I've done this work ahead of time, but it's no different than what I've done in the past. I'm going to go a times 1 cubed, which is 1a, plus b times 1 squared, which is 1b, plus c times 1, which is plus 1c, plus the 1d I have here. And I'm going to call it a plus b plus c plus d. When I get to my second number, 2, this is my 2 cubed times a. This is my 2 squared times b, my 2 times c, and then my d. My third term is me going 27, or in this case 3 cubed times a, 3 squared times b, 3 times c, followed by d. I need to know how this switches. If I had 1 apple, 1 banana, 1 cherry, and after having that much fruit, I want something unhealthy, so 1 donut. And now my fruit bowl has 8 apples, 4 bananas, 2 cherries, and still 1 donut. I want to know that I added 7 apples, 3 bananas, 1 cherry, no new donuts. I wanted to do the same thing for the second and third term, and so I came up with 7a plus 3b plus c. To go from the second term to third term, I added 19a plus 5b plus c. To go from the third to fourth term, I added 37a plus 7b plus c. I am not finding a finite difference here. So I would have told you the same thing I told you on top. Take the chart out to another degree. Take it out so that now what's the difference between the 7 apples, 3 bananas, and 1 cherry, and the 19 apples, 5 bananas, and 1 cherry? And it is I've added 12 apples and 2 bananas between that little part, between those bowls. But that's not the same as what happens between the second and third term. There I added 18a plus 2b, and that's not the same as what I did between the third and fourth values here and here, which is 24a plus 2b. So I have to still go find my finite difference, and my finite difference is constantly adding 6a to these values. 6a, 6a. So this is my finite difference. Which I'm going to match up eventually to my 60. But in these problems, I'm going to ask you to find the next 2 terms. I would like you to do this recursively, which means I realize that my 60 here has to be added by 282. It has to be added to 282, which will then give me 342. I'm going to take that 342, add it to the 809, think that's 1151. And I'll take that 1151 and add to the 1829. And that's how I'm going to get my 7th term or my next term, which is 2980. The process is not going to change when I do my 8th term if I want to do it recursively. Take the 60, our finite difference, add it to the 342. This will be 402. Take the 402, add to the 1151, and you come up with 1553. Take the 1553, add it to the 2980, and you come up with 4,533. Not only are these the next 2 terms, but these are 2 terms that I could then go back and check once I have my formula figured out over here, and I can re-verify those numbers by using an explicit formula, which will then confirm that I did come with the right formula, which means then I can use that formula to come with the 86th term, because there's really no one fun way of doing this manually to get to the 86th term. So now I want to do is match up my table on the bottom to my pieces on top, and so I'm going to recommend just put your focuses on the top diagonal and start with the finite difference. If your finite difference is 60 and your finite difference on the table is always 6a, use that, set them equal to each other, and then solve for a. So if 6a equals 60, then a has to equal 10. Then work your way up the chart next. 12a plus 2b has to be the same as 102, because the 102 is in the spot that says you are to equal 12a plus 2b. No matter how complicated this 3rd degree polynomial is, or this 3rd degree sequence, that's going to be the case. So I'm going to set 12a plus 2b to equal 102. I'm going to fill in my 10 for the a. 12 times 10 is 120. And I can work that out once I say 120 plus 2b equals 102. 2b will equal negative 18. b equals negative 9. I now have 2 of my unknowns that I have figured out. And from there, work up the chart again and say, all right, the first difference that we had to find between the 2 terms is 7a plus 3b plus c. And I'm telling you that is equal to 41. So that's what I'm going to do. I'm going to set it up. 7a plus 3b plus c equals 41. I'm going to take the 7 times the 10. I'm going to take the 3 times the negative 9. I'll use that to figure out c. 70 minus 27. What do I have to make the adjustment to get to 41? Negative 2. C is negative 2. And you'll see up here I've got 10n cubed, I've got my negative 9n squared, I've got my minus 2n. All that's left for me to find is d. It's a plus b plus c plus d. You plug in 10, negative 9, negative 2, make it equal to 4 with the plus d on the left side, and you're going to come up with d equals 5. And you got yourself a formula. I'm going to recommend you check it out. So take your calculator. Okay. You can manually just go 10. Let's try it again, 10. And since I wanted to figure out what my 7th term is, because this is 1, 2, 3, 4, 5, 6, 7, I could check that out, see if I do come up with 2980. So I could go 10 to the times 7 raised to the 3rd power. I could then go subtract 9 times 7, which is then squared. I could then go minus 2 times 7. And I could go plus 5. I could hit enter, and I could come with 2980. And I'm feeling pretty confident that not only did I do my formula right, but I did my recursive elements right. If you really want to take advantage of your calculator features, consider putting this into the calculator as a graph. 10x cubed minus 9x squared minus 2x plus 5. Let's go back and look at the table. where I go second table set. If I want to confirm that all my numbers are right, I could go 1. I could go down a delta table, make that count by ones. That's all it means, counting by ones. And then when I hit second graph, I can confirm I got 4, 45, 188, 493, 10, 20, 10, 18, 29, 29, 80, and 45, 33. So I know I have that right, and I know my formula is correct. I'm feeling really confident. If you want to do what eventually will be the 86th term, okay, I could do what I did here. I could go 10 times 86, raise it to the third power, minus 9 times 86, square it, minus 2 times 86, and I could add 5. I could hit enter, come up with that number. But let me just show you a couple things you could have done. The ability to do what is called taking your independent variable and asking. And all that does is when you go to table, you get to choose your values of x. So if you want to plug in 6, 7, and 8 and confirm those numbers, you'll also be able to confirm 86. You'll notice that that number's larger than this value. So you're getting scientifically notated numbers, but if you move over to the cell, it's important to see that you actually see as many digits as possible, and you'll get your correct answer. But I'm going to show you one last little thing. This is something that we also use quite a bit in other classes. Go hit your vars key. Go over to yvars. Go to function. Do you remember us putting it in graph y1? Choose y1. If this would have been written, before I go any further, if this would have been written as f of x equals 10x cubed minus 9x squared minus 2x plus 5, you would have gotten this answer by going f of 86, and it would have been the same thing. You have the ability to do that as well with this calculator. You can think of y1 literally as a function. If you recall, when you hit the vars key and you go to y's var, number 1 was function. So what you can do is you can actually go y1 of 86, and it's going to put 86 in for x, and you'll get the answer that way. So if you wanted to do y1, and by the way, I'll just cheat a little bit and hit second enter, and you wanted to find that 8th term, there's y1 of 8, and there's how I get my 4533. So there's another way that you could take advantage of the calculator's feature, especially if you plug it into the formula. We'll just do one more quickly, and I'll just go through the process one more time. You got the numbers 11, 20, 23, 8, negative 37, and negative 124. So as I figure out the difference between 11 and 20 and 23, and 23 and 8, and 8, negative 37, and negative 124, and realize I do not have a finite difference in the first degree, and I take the 9, 3, and negative 15, negative 45, and negative 7, and find out those differences, and realize here I don't have a finite difference in the second degree. And then I take that one more time and I say, okay, what's the difference between negative 6, negative 18, negative 30, negative 42? And when I finally get to the third degree and I come up with negative 12, now I know what I want to set that equal to be 6a. You're still going to be asked to come up with the next two terms. You're going to want to take negative 12, add to the negative 42, come up with negative 54. You're going to take the negative 54, add to the negative 87 to come up with negative 141. You're going to take the negative 141, add to the negative 124 to come up with negative 265. Yes, it's wordy. But it's a recursive process. And you'll get negative 265. And then you'll do it all over again, where you take the negative 12, add to the negative 54, come up with the negative 66, and then negative 66 gets added to the negative 141 to come up with the negative 207, which is then added to the negative 265, so you can come up with negative 472. I can get those problems without ever figuring out what the formula is. But if I want the formula, I want to match up the pieces. Negative 12 goes to 6a. I'll figure out what a is. 12a plus 2b is going to go to negative 6. 7a plus 3b plus c is going to have to equal 9. And a plus b plus c is going to have to equal 11. And as you go through all the work, and you figure a is negative 2, and b is 9, and c is negative 4, and d is 8, you will come up with an explicit formula. Hopefully I have emphasized to you how valuable this calculator can be if you decide to plug that into your, as a graph, as a function, as y1. Just remember to use x's. Negative 2 x cubed plus 9 x squared minus 4x plus 8. Feel free to start your table at 1. Count auto. Verify that everything's matching up. Hey, look at that. Everything is a match. You can even go down and confirm those next terms. But if you want the 42nd term, you could change this back to ask and then type in 42. But again, I'm going to just throw a crazy idea out there. Why don't you use the feature of the y vars and just think of it literally as a function. Think of it as the y1 function, or y1 of 42, and you'll plug it in. You'll get negative 132,460, which all it's doing is plugging in the 42 into the formula in that spot. And you can have done that manually. And that are third-degree polynomials.